Hello and welcome to this webcast, brought to you in association with 451 Research, Azul Systems and Hazelcast. Thanks very much for joining. We will have time later on during the call for some Q&A, so feel free to use your interface to send us some questions as we go along. My name is Jason Stamper. I'm an analyst with the 451 Research Group. I'm also going to be joined today by Giltine, who's CTO and co-founder of Azul Systems. And we're also going to be hearing from Christoph, who's Managing Developer Relations at Hazelcast. So I'm going to be talking about speed and scale and why you need both. First of all, very briefly about 451 Research. Although we're not very well known, we're the fourth largest technology analyst firm in the world. We were founded in 2000 and over 200 employees. And we, as well as interviewing vendors and end users of technology, we do a huge amount of survey work, which helps to give us a good idea as to what's really going on amongst end user buyers of technology, so that we kind of keep in check what some of the vendors are saying as to what the market is also saying as well. So we publish over 4,500 reports a year. We cover over 2,000 technology and service providers. And we've got a number of offices around the world. I'm personally based in London. So moving on to the topic of today's session then. As far as we're concerned, in the data platforms and analytics space, there's something of a perfect storm occurring in the sense that there are new challenges on businesses in order to be more responsive, to be more flexible, to be faster and to react more rapidly to changing dynamics in the industry, to compete with your rivals as fast as you possibly can, of course. And at the same time, the technologies, of course, as we know, are changing very rapidly. So the computers in our pocket, our mobile phones, our smartphones, 15, 20 years ago had, 16 or 28K of RAM, and now as powerful as the mainframes of the 60s. So we've seen this huge change, of course, in terms of mobile and social, also the use that we're all using in our personal and professional lives of cloud technologies, consumerization in the enterprise, big data, of course, we're trying to analyze larger data sets more rapidly, and increasing the Internet of Things, which I'm going to talk about shortly. Of course, at the same time, all of this brings a huge amount of challenge for the CIOs and IT decision makers in an organization, who are increasingly finding that their end users, the business people in their company, consider themselves IT experts, of course. So, 50 years ago or 20 years ago, when I started my career as a tabloid journalist, I didn't have email on my desktop. I had to go to the IT department and ask them to print it out if I'd had an email sent to me. And increasingly, these days we're finding that business users, like I would have been in those days, not only consider themselves experts in business intelligence because they can use tools like Google and Bing and so on to very quickly and rapidly find decisions, but they also, of course, set up their own home networks and configure their own 1 terabyte USB memory sticks, and are very surprised when the IT department is not able to supply them, and of course, very importantly, their customers with very rapid, very responsive IT applications and services. And all of that is creating something of a trust problem between IT and the business, and indeed between companies and their customers. So this was a survey, for example, amongst 200 UK-based CIOs, when asked what kind of a gap there was between what the business and their customers expect and what IT is able to deliver today. It found that 98% of those CIOs, obviously nearly all of them, found that there was a very significant gap between what the business expects and what IT is actually able to deliver. So what does the business want? None of this is hugely surprising to any of you, but it is worth reminding ourselves, given how fast the technology industry moves, what the business is looking for, because obviously as technology analysts and writers and developers and DevOps and so on, it's easy to forget some of these things that the business is expecting that we might perhaps forget. Those of you who are petrol heads will recognize all of these cars, points on the scoreboard kind of thing, but the top left one is a Bugatti Veyron, at one time the world's fastest on-road sports car. I'm not sure if it still is, but so obviously speed, low latency, the ability to react very rapidly to decisions is obviously very important. That's one of the reasons that in-memory technologies are growing so strongly. The next one, going clockwise then, is an on-display information screen. The idea that industries and their users want information and not just inaccurate data. You need to know what's happening, when and where. We've heard this a lot before, but this idea of business reporting, where you look in the rear view mirror to see what's been going on in your business, is no longer acceptable. And we need to look ahead using increasingly real-time analytics and also the ability to do some predictive analytics to see what's coming down the line rather than just seeing what's behind us in terms of a business. The next one, going clockwise, many of you will recognize the Land Rover Defender, not the most aerodynamic car ever designed, top speed of about 75 miles an hour, even though it had 160 horsepower. But that talks to the idea of control, governance, security, which obviously is still absolutely critical. The next one around there, many of you won't recognize, perhaps. That is a Skoda Rapid 1.2 litre. It was known as the Czechoslovakian Porsche 911 because the engine was in the bonnet, in the boot. That was my first ever car, actually, as it happens, and it was terrible, 0 to 60 in 16 seconds. But I put that on there as well as the Mitsubishi Latency on the left there to talk about the importance of meeting your budgets, because the Mitsubishi Latency there is the car that was famed in Top Gear's star in a reasonably priced car section. And that's to sort of talk about the fact that, we'd all love a Bugatti Veyron and a Land Rover Defender combined, but we also have a budget to be aware of. So specifically today, what we're talking about are some of the challenges around scalability and latency sensitivity. And, I've already talked about, the car analogy works reasonably well to explain, the pressures that users and customers are facing in your business and the responsiveness challenges that your IT technologies and infrastructure is facing. So, I don't really need to spell it out, but I have just in case. So increasing numbers of users and transactions. Of course, we're going from the days of an airline which used to sell 2 tickets a week to online gaming companies that have 1,000 transactions a second. We're talking about much more data, even though it might be smaller bits. It's not so much that big data is the size of the data, it's the frequency of the data and the number of transactions that we're being expected to cope with these days. And many of those older relational technologies weren't really designed for this kind of environment. And for those reasons, we're seeing latency growing. And I put at the bottom there, every vertical sector is affected somewhere, because it's not just low latency systems, algo trading and so on, where this is becoming an issue. Anytime a user interacts with your website, your customer-facing service representatives, a retail branch, the ability to analyze data in real time and understand really what's going on is affecting all sorts of industries, not just those ones that we traditionally perhaps thought of as the very lowest latency requirements. And that's why 451 Research believes that this affects all sorts of areas. So as I've mentioned, our organization does in-depth research with 15,000 end users of technology each year, and this was our latest research. This was Q1 2016. Down the left-hand side, you can see the growth rates, CAGR, between 2015 and 2020, as we've forecast going forward. Now, Hadoop is an interesting one. A lot of people are putting a lot of data into Hadoop, and so, of course, it's growing very rapidly. But Hadoop itself doesn't give you a huge amount of drama. It doesn't give you a huge amount of detail and so on. Many of the analysts, including ourselves, are calling it a data lake or a data swamp or data chaos. And there's this wonderful marketing term, which is, schema on read rather than screen on write, which is that you start to analyze the data only when you get it out of Hadoop. So Hadoop is an interesting one. It's a way of putting a lot of data into commodity hardware, and we know there's a lot of data we need to store, so that's one way of doing it. The more interesting bits are the ones below that, which is where we start to see some kind of analysis of that data, analytics and technology being applied to that data to give us some real value from it. And as you can see there, we found that distributed data grids and caches were seeing very high growth forecasts for the next number of years. And we think there are some very important reasons behind that. The in-memory benefits of data grids and caches really give you some of that real-time data feeds that I've talked about. So that was just a brief introduction from me, and now I'm very delighted to introduce you to Christoph Engelbert from Hazelcast. Christoph, over to you.
Thanks, Jason. Yes, I'm Christoph Engelbert. I'm Manager Developer Relations at Hazelcast. I joined Hazelcast in roughly November 2013 as one of the core engineers. Nowadays, I'm taking more care of the Java community, of especially the Hazelcast community, but Java in general, of a lot of different communities where Hazelcast kind of goes into and tries to help people, and also about customers, our customers, but also prospects that want to become customers. I would consider myself a Java passionist. What I mean is I'm really trying to get Java better. I'm trying to get Java forward, and I think that is a very important thing. We already heard from Jason that Java is very important. We've seen that in-memory data grids are growing, Hadoop are growing, is growing, and all of that actually works based on Java. So Java is a major key player in the industry where Hazelcast and a lot of other companies are in. Apart from that, I'm mostly interested in all kinds of performance things, benchmark fairy tales, since we all know there is no benchmark that tells you the truth. I think that's basically it. Jason, can you go forward? Thanks. So from the Hazelcast perspective, we see ourselves as an in-memory caching solution or an in-memory computing platform. That is basically the area that Jason just said that is rapidly growing. That means to hold a lot of data in memory, we actually partition data, which means if you have multiple nodes, we keep a subset of the overall data set in each of the nodes. That means we can scale out pretty well. We just need more nodes to store more data. And we also have this whole tolerance built in, which means we just store some backups somewhere else in the cluster. For Hazelcast itself, and what is different from a lot of competitors, Hazelcast is all about the ease of use, or the ease of use. That means we try to be as easy and as intuitive to any kind of developer as possible. Mainly Java developers, that is where we started, but we see that we have lots of more clients by now. We have a Scala client, we have a C++ client, a Node.js, Python, C#, and PHP is in the working. So there's way more stuff upcoming. I think this is it from me. And Jason, can you? So I hand over to Gil Tenney, my nice co-speaker at this webinar.
I am the CTO and one of the co-founders of Azul Systems. And I've been working on various types of runtimes, including Java runtimes, for a couple of decades now. My focus has generally been on responsiveness, consistency, and reliability of systems like those, including, obviously, the performance aspects of them. And at Azul, I've gotten to do quite a bit in that space, dramatically working on Java runtimes, their behavior as a platform, as a virtual computer that many of these technologies run on. The various technologies that exhibit this very high growth rate that were mentioned by Jason before, are all based on Java and will run on Java runtime platforms. And it really is the performance of those platforms, and therefore the performance of those specific technology areas that I've been focusing on for the last few years. If we move forward to Azul systems, and Zing description, the specific product that we're focused on in this webinar from Azul is called the Zing JVM. The Zing JVM is really a Java runtime that executes pretty much any Java application on a server, but solves many of Java's problems with consistency and response time and execution. Specifically, it eliminates the pausing and what's called the garbage collection problem in Java, resulting not just in fast execution between hiccups and stalls, but in an execution that is consistently and always fast. And it delivers this across an extremely wide range of operating environments. Zing can be used anywhere from a gigabyte of memory at the lower end of server computation, all the way to terabytes of in-memory capability. And also from machines that are as small as a couple of cores to ones with hundreds of cores, and everything in between. Across that entire range, you get smooth executing Java, and therefore smooth executing whatever it is that runs on top of Java. So Java platforms like data grids, like stream processing, like analytics, like search, can all execute smoothly without hiccups or stalls or freezes that have been traditionally a problem in the platform. That is our focus as a technology. And when we look forward from there, I think that the combination of both our technology for running a Java platform and Hazelcast technology, which is based on a Java platform, make together for a very good combination for customers. So I think, Jason, we can move on to the first talking point area.
Yes, absolutely. Thanks very much, Gil and Christoph, for your comments as well. So I think the first thing we were going to talk about, Gil, was why organizations should specifically think about building their own solutions to this challenge, or whether or not they should be buying what's already built. One of the difficulties that they might face trying to do that, building it themselves. I mean, there are a lot of open source technologies, for example.
So I would say from Azul's point of view, we see a lot of places where people evolve their own homegrown solutions, whether it's their own software that was built, infrastructure pieces that were built themselves, or taken from various projects and have been around for years in-house, that have diverged from what is widely available or supported by others. And that's usually because there was a need at some point. Somebody needed to build stuff, they were smart enough to do it, it served a purpose, then slowly things grow from there with requirements. In our business, where we see this the most is as people scale and try and use more of their systems for more complexity, they tend to have internal development of extreme tuning and tweaking and fine-grained performance management capabilities just to keep the platforms themselves running. And from Azul's point of view, one of the places where we've been able to save a lot of work is just getting something that works better than tweaking and building yourself. I think that Chris can comment on the Hazelcast part of people building their own caches and data grids, which is interesting.
Yeah, exactly. So from the Hazelcast perspective, I totally agree with you, Gil. It often doesn't make sense to create your own solutions, but what happens is that a lot of times people did it in the past. There was no solution up that time, so they started to create their own. Often people also have this feeling like, it doesn't exactly fit our needs, so we need something different, or they start forking something and extend it. And especially for caches, I think one of the main reasons to do that is because people expect caches to be simple. I mean, it's just a hash map, and you have some methods around it, and that's basically it. The problem is that this is not everything that a cache is in the end. So you start adding more features. You need TTL, so time to live. You want to have your objects or your cached objects to expire. You want eviction if you run out of memory, well, before you run out of memory in the best case. And all those things. So caches are not as simple as people think. You probably don't think that.
Yeah, and I think what I've often seen and customers we deal with is that they start with a simple internal implementation of something that looks like a cache, but when they look at the business actual need of what this tier needs to do, it hasn't been thought out from the start. Once you start adding scale, the need to run across machines, the need to replicate data for availability, the need to actually be able to handle more than one machine can handle from a point of view of speed or capacity or just sheer volumes. The organically grown solutions start cracking. And at that point, what we often see is people adding more and more work to them to keep them running, instead of taking a step back and looking at what's available to replace them. It's the mature people, it's the people that end up focusing on their business needs as opposed to their technological hobbies that we think end up looking at what can they take that already works and would plug in pretty much to the logic that they have. And I think that that's where both Hazelcast and Azul have products that fit in very well, because they fit into what people already do. They just do them better, simpler, scale dramatically, easier, and reduce a lot of the work that needs to be done internally otherwise. I like to refer to these as heroics. People often go in and apply true heroic things just to keep stuff running, and they'll put duct tape around things just to stop them from breaking. And one of my favorite images to use in this sense, and Jason, if you flip to the next one, is actually this image about the ultimate and heroic duct tape engineering. This is literally fitting a square peg into a round hole in order to keep a spaceship running for millions of miles away. This is the Apollo 13 CO2 scrubber that actually saved 3 astronauts' lives by being able to engineer it into a wrongly fitting. And it's great that engineers are able to do that. They will often evolve to doing this. But it's also important to understand that they shouldn't need to, that this is a last resort. This is what you do when you fail and you survive the failure through heroics. But usually what you want to do is find the round peg for the round hole and get one that works well.
I think what is an interesting fact about those heroics is also people try to work around the issue with Java heap and that you can't keep growing it constantly. So what we see at Hazelcast often is that people try to start multiple JVMs on the same machine, which kind of works against the idea of distributing backups and distributing the data, but you kind of grow your heap by just moving it to different JVMs.
Yes. Yeah, I call that building a distributed network inside a toy computer, which we see people doing quite a bit. Fundamentally, when they reached a point where their single units don't work well anymore, not because the computer can't fit them, but because the runtime they're running on doesn't work well, the scaling isn't there, whatever their own software doesn't scale beyond it, they'll often try to replicate a lot of little parts inside one computer rather than across computers. Yes, they will replicate across computers for scale, but when you need 20 little pieces just to keep one small $5,000 computer fed, that's usually a sign of architecture that's gone way beyond this duct tape engineering mode. And really it's where you go and look at mature technologies and say, okay, what do people actually do to make use of these capacities to handle these loads, these actual business requirements, and what do they do today in this decade as opposed to a decade or two ago to solve them? And that's where looking for best of breed solutions in the individual parts is really important. I think Hazelcast makes a great best-of-breed solution for a cache and a data grid for in-memory data technology. Zing makes a great best-of-breed solution for executing the Java platform that Hazelcast runs on, or the Java platform for other applications as well.
Okay, thanks, Gil. And you made an excellent point earlier about the importance of Java. Why do you think it is important that some of the technologies I put up in my slides around the highest growth areas for data processing and analytics technology happen to be Java-based? Do you think that's important? Is it relevant to industries and companies that Java's behind these types of technologies?
Well, obviously, I would think that it's important. Our company focuses entirely on Java runtimes. But I think that there are very good industry trends to attest to the fact that Java pretty much dominates these kind of processing environments. And when I say Java dominates it, I don't mean that the programming language or the interaction with the actual user is Java. I mean that the pieces of infrastructure used to power it are running in Java, are built in Java, and therefore execute on Java runtimes and on computers that execute those. So whether you look at Hadoop, and virtually the entire Hadoop stack is in Java, whether you look at stream processing and search, or whether you look in this case where we're focused here, and one of the highest growth rates in the sectors you've pointed out is in-memory data grids. Platforms built on Java are the ones that tend to dominate. We can speculate as to the reason why, but the data itself just speaks for itself. It is dominated by Java. We think it's because Java is a really good platform for doing it, and we can make it even better. But it may be some other choices that drive it. The important thing is, usually when you're dealing with any of these data technologies, you are dealing with Java runtimes, whether you directly interact with them or whether the thing you are using interacts with them. You're going to be running on the Java runtime on a modern computer.
Okay, absolutely makes sense. All right, let me ask you both this question then, and I think we've got a slide that sort of, talks a little bit about this. Why should our listeners, viewers of this webcast, be interested in the fact that Hazelcast and Azul systems are working together? What are the particular benefits of this, partnership? As opposed to looking to different vendors or different, solutions and so on. I don't know, Chris, if you want to start off on that.
Yeah, I think Gil already made a perfect point. He said that Azul in it as Zing runtime is very good at executing Java code. It's way better than the hotspot for any kind of predictability for latency sensitive applications. And Hazelcast is exactly that. People want to have a cache being predictable at response times, predictable at especially at things like the write throughput, but also the read throughput, especially if you have a cache that has a higher read rate. And I think Hazelcast and Azul at that point meet up perfectly and is like this perfect underlying runtime system for your own application to be being built on top of that.
Mm-hmm. Yes. And I think from our point of view, the two companies fit together very well. We're both also very independent of each other. Hazelcast is a data grid and cache platform that runs on Java. It'll run on any JVM, not just on Zing. It just happens to execute very well on Zing. Zing is a JVM that is built to run any Java platform, Hazelcast included, but many others as well. And outside of the space of data grids and caching, we do lots of other things, including web applications. The place where these two intersect together is where people want the functionality and the benefit and the speed of an in-memory data grid and the cache combined with the scalability and predictability of latency that comes from the very healthy Java runtime rather than one that was designed really for individual web browsers and tends to glitch a lot. So the combination of the two together gives you a highly responsive, very consistently executing and very scalable data grid solution. And they fit in very well together. I think that one of the things we could look at is to explain or to dive into this notion of why consistency of latency matters, not just latency speed, but consistency of the latency speed. This really comes down to the fact that, as you pointed out, Jason, applications today tend to have high demands from a real-time interaction point of view, from an interactivity point of view. There are humans waiting for answers. Humans tend to be impatient. Humans tend to remember when you did something slow or bad. And they don't think in averages when they experience stuff. You don't think of, on the average, things have been good. You think of the slight or the offense or the annoyance that you had from having to sit there for a couple of seconds or a couple of minutes waiting for something once in a while. And responsiveness is a very important behavior criteria for infrastructure, like an in-memory data grid.
Yeah, I think you made a perfect point here, that most of these systems that also Hazelcast is working as a backend solution, or is working for as a backend solution, is often seen by customers in one way or another. That means there are actual people waiting for responses, there are people waiting for the answer, waiting for a report or whatever is generated based on what Hazelcast can deliver.
Mm-hmm. And I think Jason, our next subject slide is about percentiles and why they matter. If we look at, why do response time percentiles matter, not just averages, it's important to think of it from an end user point of view. An end user doesn't think of you being polite on the average. They think about whether you're offensive sometimes. They similarly think at anything that is slow that affects them as slow, even if other things were fast. So usually when you want to think of a user experience, whether it's a person or a business partner or an API across the web, in terms of how many things or what are the chances of experiencing a bad behavior, not what the average is, but what are the chances of something bad going on? And this is an example of a good hypothetical question. What is the chance of a user experience something larger than the 99th percentile latency of one of these internal kind of technologies, a key value store like a cache, or a database lookup, a more complex query system usually, or just one application node of your application or the whole cluster? What are the chances that somebody will actually see that and get annoyed at it? And the next slide we have actually shows some answers to those chances. These are actual samples from the front homepage of actual websites, looking at how many individual web requests, just HTTP requests, clicking on one screen generated. And you can see that those are in the high tens to low hundreds on most sites today. On the right, you can see the chances of one person in one click seeing the 99th percentile or worse of some internal metric like HTTP request time. As you can see, most interactions with a web page will see and experience the bad things. And that's because there are many things happening and many requests or many lookups happening in the interaction of one user turnaround. That's a very important thing to keep in mind, because what it means is that the percentile of people that are experiencing bad behavior is very high, unless if you take cumulative action into account. In fact, in the next slide, I think we have a stat that shows that for most web applications, the 95th percentile customer will actually experience worse than the 99.995 percentile response time. And that means 5% of your customers are seeing something as bad as that percentile. It's why you care about the percentiles. It's why they matter. It's why looking at what the behavior is into those percentiles is important, because it tends to dominate bad behavior that customers see.
And I think
sorry, Chris, go on.
I think the important thing here is to note that I, as a customer looking at a web shop, I'm not seeing the overall picture. I'm not seeing that, like, most people get a good response time. I just see that I get the bad response time, and I'm waiting in front of my computer, waiting for this website or for the shop to actually load the pictures or the product.
Yeah, and the way to think of it is if 5% of the people had an annoying reaction, the next day you'll have fewer people. And the next day you'll have fewer people. And every day you'll shed 5% of those until you have no customers. So there needs to be a quality level. Perfect isn't needed, but high attention to consistency is important. It's not just okay for 50% or 90% of things to be good and other ones to be bad. You need multiple nines in what you're looking at. And this is really where the focus of a combination of Zing and Hazelcast together delivers.
That's what I was going to ask about briefly, Gil, is, you talked about, the importance of kind of response time. I suppose some people listening to this webinar might think, well, hang on, that doesn't really affect me. We've got quite good supply chain management systems in place. Our website seems to stand up. Is this only about the occasions when it's coming up to, Cyber Monday in the UK, as they call it, when there's a big rush on sales just before Christmas, or, the Black Monday sales in the US, or Thanksgiving, or is it about the peaks, or is this something that companies should potentially be mindful of year-round?
So I would say peaks are certainly important to design for, because most businesses that fail at peak fail. Businesses that cannot actually satisfy orders or take orders on Black Friday, one day of the year in the U.S., tend to fail. It doesn't matter that they're good the rest of the year. They lose customers and lose revenue to competition, and those customers don't come back. In other sectors like trading and Wall Street, you will also see the same kind of thing where, peaks are what matters. That's where money is made and lost. That's where fortunes are made and lost. But I think that across the board, it isn't really the peaks. It's the continual behavior. When we talk about percentiles, we're not saying that 1% of the year there's a day that something happens. We mean that every second, a certain number of people are experiencing that behavior. Even at low load, this will happen. So it is important to see under the load that you run and with the machines that you have, what the user experiences on a regular basis. And not just at peak times, but at all times.
Okay. Would you go along with that, Chris? Do you think it's about measuring and monitoring kind of year-round, and to what extent do you think prediction is important in this space as well?
I think the predictability is very important. It's not only, as Gil said, about a few certain days in the year. It's not essentially about the industry you're working in. I mean, we see that in a bit, that all of the different industries we're working in are basically very, very predictable, or need to be predictable at all times. And Gil had this example with trading. Obviously, also in trading, you have this huge peak in when the market starts in the morning, but still you want to be predictable and consistent over the whole day, not only in the morning, because still this is probably where most money is made, but you still don't want to lose money over the day.
Yes. I think, in trading, it's very easy to explain that if you react slow to the market, you lose money. If the market prices have moved and you act on old quotes, you're probably going to be, lose money to others that are much better than you. But beyond places like trading and like life and death situations where consistency is obviously important, even in places like retail shopping, people react badly to bad consistency and they stop shopping. They move on to another site. They decide not to check out from their shopping cart. Those are things that hurt revenue, and they hurt it in a large degree. Similarly for ad placement and other things as well. I think that looking at how our platforms together deliver very good responsiveness is an important thing to highlight as we go and look at the various use cases. I think our next slide actually shows results for that, where what we're looking at here is a simple, actually directly measured chart with the vertical axis showing response time and the horizontal axis showing the percentile of operations that experience those response times. Remember, these are cache lookup operations, not user interactions. So for every user interaction, there are probably hundreds of these operations needed. But you can see the vast difference between running the Hazelcast platform, which is very healthy and scalable on its own, on Hotspot, and running that exact same platform using the Zing JVM to power its Java platform. And the difference is immense. We're talking about multiple orders of magnitude of reduction in both frequency and magnitude of the bad things. So bad things, high response times, happen a lot less often, and when they do happen, they're a lot smaller than with Zing, than with Hotspot running exactly the same workload. And while Hazelcast is a platform, delivers all the functionality and reliability and scale and availability that it does, running it on the right Java platform also provides this extremely good latency behavior and consistency.
Yeah, I think the consistency, again, is pretty much what matters to most people, or what should matter.
And that's an interesting point to reiterate, I think, both of you, is from what I've understood from what you're saying, is it's not just about low latency, it's also about the consistency of the latency, so that the applications aren't either waiting for data, but also being overloaded by data and then having to catch up, if you like. Does that sound right, Gil, that it's also about the consistency of the latency rather than just getting down?
Absolutely. I think that way too often people look at speed as, look at how fast I can sometimes go. But if you sometimes go fast and sometimes have terrible speed, in most actual real-world use cases, that terrible speed tends to dominate the experience. So just because you can run really, really fast 99% of the time doesn't mean that the 1% is acceptable. In fact, it often means that really translates into, you're not really, really fast 99% of the time. You're really, really slow 1% of the time, and that's the problem. And with Zing, what we focus on is consistent speed. So speed is something we do all the time, not just some of the time. And we look for that consistency. The quality of a platform that runs and then stops for parts of a second and then runs again are not desirable in a computer. They've never been desirable in a computer. And we see them as an unfortunate mistake made 20 years ago that people hadn't bothered to fix in Java when they built the platform. It's not inherent to the platform. But it's unfortunate it's been around, and Zing really eliminates the problem and fixes it without changing any of the requirements for a Java platform to run. So it runs anything in Java just without the problems.
What I think is quite interesting, the discussion we had previously to this webinar about what we actually want to tell people is it's not always about the lowest latency, just as you said, Gil, but it's about latency sensitivity. So you don't need to be the fastest, but it's important that you be sensitive to the consistency, to the latency being consistent, or the response time being consistent for customers, for users, for trading, for pretty much everything you have out there that is running on computers.
Yes, not timing out on a user request is much more important than satisfying a user in a tenth of a millisecond, which they don't care about. So it's what users see, whatever the application needs, and the level of latency needed for different applications varies, where, in trading it might be microseconds or parts of a millisecond. Humans usually think in terms of hundreds of milliseconds. And in between, we have a lot of computer-to-computer operations that is critical at the tens of milliseconds level. So what we usually see when we look at pieces of infrastructure, like databases, like in-memory data systems, they need to respond in sub-millisecond times for the system as a whole to be healthy, because many, many operations will be asked of them in order to do one human visible thing. They usually don't need to work in microsecond levels, but they need to respond in sub-millisecond levels and respond at those levels at very high volumes, at very high complexity.
Okay, thanks very much. So let's move on to the next area of discussion then, if we might, Gil and Chris. You've talked about this already to some extent, but why is it so important that, latency sensitivity is managed carefully, that we absolutely ensure, if we can, that latency is kept to a minimum, even in areas that, like we have said, are not necessarily what we might have considered in the past, low latency areas like algo trading and so on. I don't know, Chris, if you would like to start off in fraud detection.
Yeah, I think what is important about fraud detection, there's a high volume of requests coming in, figuring out if a request might be something bad or not, and you can't exponentially scale up on response time when this high volume comes in. It's probably that your fraud detection algorithm is pretty fast, or is maybe the fastest in the market if there's just one request, but you want to have this at high volume and you want to satisfy this high volume for all the customers.
And I would say, if you look at a common two examples for fraud detection, first and easy one to understand as any consumer is when you swipe your credit card at a store, there's a limited time budget to decide whether or not to accept your transaction. And usually if that takes more than a couple of seconds, you get annoyed. You might even try again. You won't be sure what happens. So throughout the system, electronically, somewhere a decision is made whether or not this is an okay transaction to do. And by the time you get back to the back-end systems that need to make that choice, their budget is usually a couple hundred milliseconds at most. They need to make a choice within that time. If they can't, they face a very hard choice. They need to either refuse and time out and deny your transaction, which would cause a phone call and an annoying customer. Or they need to actually accept the transaction not knowing whether or not it's okay, which means financial risk. Both of those are unhappy situations. So the higher the number of outliers where you take more than 100 or 200 milliseconds to make a choice, the more you've exposed yourself to either angry customers or financial risk. That's one example. But an even more important one that's coming up in fraud detection today is that fraud problems are now coming in orchestrated attacks. It's not just one person doing one operation that's bad. It's often a ring of bad people getting hold of 15,000 credit cards and executing on all of them in the exact same second. And their hope and goal is to fleece the financial system out of tens of millions of dollars potentially in a couple of seconds before the system even understood what is going on. So your time to process that volume of attack is directly affecting the amount of money lost to fraud. The more quickly you can react to coordinated fraud attacks and to time-based ones, the more you can see patterns across operations, patterns that didn't exist a second ago but do now, the more you can contain the loss. And that seems to be one of the interesting areas in fraud detection today, from what we understand from our customers. And it's certainly one of those places where consistency matters dramatically. It's not just that you sometimes need to be fast, it's that you need to know, not have outliers and not miss these things because they cost.
Gil, would you like to talk about gaming a little bit as well? I know that's an area close to your heart.
Chris, I think gaming is
yeah.
your function.
So there's a little gamer in everybody of us.
Yes.
So the other thing, I'm not sure how many people in the audience are actually gamers themselves, but I've worked at Ubisoft, which is one of the biggest gaming companies in the world, and if you create online multiplayer games, it doesn't matter if it's like a first-person shooter as in the picture right now, or if it is some other kind of or an action combat system, real-time combat system. This latency on the server side needs to be very, very predictable, and in this case also pretty low because you add this ping time from the player to the gaming system itself on top of that. So you already have this unpredictable network latency, so you really want to make sure that your game servers have a very predictable runtime, because that means you can try to mitigate the actual problem. On the next slide, I try to show how it actually looks like. So this is not me playing, but I found it on the internet. The main idea here is this red area is where the boss will actually do his attack. So your plan is to get out of this area before you're actually being hit, or before the cast from the boss is done. So what actually happens if you have a bad latency on your network or on the server side is you see yourself already being out of this area, but the server still thinks you are inside that. And that gives you this weird feeling of something is wrong. This is where the latency really is important to the user as a person itself And this is just an online role-playing game. Going back to the idea of a first-person shooter, this is even worse because somebody else, so in this case, people working together. For a first-person shooter, people working against each other or maybe in a team against team versus team. That means the person that has no lag and that where the server maybe responds pretty fast and sometimes you have multiple servers involved in a single game, there you have this situation that one player doesn't have the latency issues, but the other one has. This gives this very bad feeling. And the next slide actually shows a nice area where somebody did a test how the rating of a game or how the experience, the overall happiness of a player changes based on the latency on the laxes, this gamer term, the latency they experience. So they actually call it the quality of experience. And what we see is we have four different categories: room, city, state, country, which increases the latency based on some simulation software that tries to simulate people, players being in different countries, for example. And what we see is that the lag players in the same room, or the people that experience the lag or the latency, are still very happy when they're in the same room or city category, but it certainly goes straight down the higher the latency becomes, because those people have no chance of winning the game anymore. Whereas the unlagged players don't actually expect it in this amount of.
And I think what's very important to understand is that in gaming, I mean, we could look at gaming and say, so somebody playing a game got the wrong result, who cares? But in gaming, happiness equates to revenue. And
exactly.
Unhappiness equates to lost customers that go to a game that is better. A player who loses trust in the game, who doesn't know if a move will actually take hold, doesn't look at the cases that work, they look at the cases that don't. And even if you miss 1 in 100 cases where they did something but the server got it wrong, they'll just stop playing the game. And they'll move on. And that is absolutely lost revenue to the gaming company building all this.
Yeah, it's not only that. Remembering the first picture, we saw this 4 people in a row. And this is actually an ESL game. That means this is a real sports league. Those people playing for money. So if there's some lag going on, those people probably lose the prize money.
Mm-hmm. And then they get upset. That's kind of like a financial exchange on Wall Street that
pretty much
to the traders. Yeah. Yep.
So making this gaming area a bit of a broader idea, I try to expand it to a broader vision, and I would say what goes for gaming goes actually for the whole entertainment and communication area. So we all know this problem. I mean, we're just looking at a webinar, so video telephony, webinars, video conferences, all those things. But also SIP telephony. I mean, all of our telephone systems, or most of the telephone systems these days, are completely IP driven, which means they use SIP or any kind of common protocol. And I think everybody knows this problem. You have a telephone call and you have one of those awesome new IP-driven telephones, and you experience this lag between people talking. Actually, everybody definitely knows this from a webinar or from a Skype call. But I think everybody knows it as well from things like television. If we think about something like a satellite transmission, that is what we all experience. I'm not sure how many people know the Eurovision Song Contest. We just had it this weekend. And it's actually quite interesting if you ask for the results of the different countries and somebody stops speaking and you see this latency going to the satellite, going back down, and it's like they answering like 3 seconds later.
And I think that there's certainly the interactive fields, whether it's gaming or audio or video telephony or reaction time to things like those are natural for us to understand. The interactive things matter, and a missed audio frame or a missed video frame is something that is a lot more than a small blip. It's extremely annoying. We perceive it as bad quality. But we can look onto other areas that are not, quite as, quite as consistent bandwidth or streaming or low latency, and much more human step-by-step interactions. Like I think commerce is the next subject we're looking at. And commerce is actually one of these interesting areas where you would think that latency or responsiveness is not that big a deal because, you click on a web page, you look at it, you think about things, you click again. Yeah, you'd like it to be snappy, but what happens if it takes a couple of seconds? What if 1 in 100 clicks took a couple of seconds? Well, it turns out that in retail, this matters a lot. That it's one of the easiest places to measure the impact of longer response time on revenue, more so than almost any other area. The interesting thing that we found at Azul is that a lot of our customers are not just retail customers, but it seems like the online clothing retail is a strong industry for us, clothing specifically. And when we tried to figure out why, we found out that online clothes shopping seems to be about the most interactive experience online other than gaming. So it's not a game, but shopping, looking at a lot of clothes, browsing, clicking to see them and all that is something that needs extreme responsiveness and consistent ones. So if you click and most of them are good, but then every once in a while it takes a long time, people stop shopping. They move on to the other store they may not buy. And that has a direct effect in actual bottom line or top line revenues. So this seems to be a place
for agree that on the Internet of Things, latency is going to be increasingly important. We're seeing machine data and data coming from smart devices and sensors and so on. In the olden days or in years gone by, where we had a few transactions a day or a week on our systems, we're trying to absorb and digest and analyze data and filter data that might be coming from accelerometers and thermometers and so on every few milliseconds. So a huge amount of data potentially having the ability to saturate networks if we can't very rapidly analyze them, Chris.
I think it's not only about analyzing those data, it's also, if we take the example of a remote heat control for your home, and you have on your smartphone, you have an application. When you want to see the current temperature at home, you don't want to click it and wait for whatever just to get the response. You expect it to be immediately. So you click it, you get the response, you can change the value, and in the best case, you see how the temperature, based on your changes, actually grows or goes down at home. But on the other side, you're right. I mean, I think a very, very extreme example might be a fire recognition system. There is no chance that when there's a fire in a building, and there is some garbage collection or whatever going on, and you react 10 seconds later, it might be that those 10 seconds are way too late for you, or for the building in this case.
No. I think that the reaction time on the human level is probably a great example in what you said, Chris, because if you think about it, you're standing at a street corner and you want to turn on the air conditioner at home, or you want to know whether or not you want to turn it on. You expect to take the phone out of your pocket, hit a couple of buttons, put it back, and cross the street. You don't expect to sit there for the next 20 seconds interacting with an application. And that really is a good example of how things have changed in the world since we've had mobile phones. I think that one of the things to keep in mind or to connect to all this is, great, responsiveness matters, but how does this tie into technology? We see in-memory data grids and caches being involved in every one of these spaces, whether it's product catalogs for online stores to be very responsive, or authentication systems, or the data that is held for all these sensors in IoT. In all those cases, the move to in-memory storage and in-memory tracking is necessary because waiting for the data to come from an external system or a rotating disk or even a network-connected memory part tends to be too much. And that's where these technologies, the combination of Hazelcast and Zing, I think really serve a great purpose because we get to have that extreme scale, extreme amount of in-memory data capabilities and do it all with very good consistency without losing the consistency that we've had in the past.
Okay, thanks very much, Gil. We've got some excellent questions coming in. We won't have time to answer all of them in this webinar, so we'll try and get back to all of you. Thank you very much for your questions. We'll try and get back to some answers from Gil and Christoph to all of your questions that we can offline via email and so on. But one of them we could just have time to quickly discuss between us, Chris and Gil, is in the era of kind of containerization and cloud, where does your partnership sit with that? Is there some relevance to that in terms of virtualization, cloud, and containerization, or is that getting too abstract?
I think it's actually a very good use case. It depends where you start with containerization. If you use Docker, I'm not sure how deep Azul is integrated into Docker. I think Gil can give you a way better opinion on that. But I think what is important is about this whole containerization is the ease of deployment. I think Gil can talk on the Azul side of things.
Mm-hmm. Yeah, I think the way I look at it, both technologies, both Hazelcast and Azul, are built to run on general purpose computers on regular operating systems, which today mostly means x86 and Linux environments. Yes, there are some others as well, but those are the common ones, especially when you look at cloud and container technologies. To be fair, there are some Microsoft-based technologies as well and others you can look at too. Zing and our product line works the same across the board, whether it's a physical machine with what we call bare metal, or a virtualized machine with hypervisors, or a machine in the cloud on Amazon, or a container on Docker or other forms of Linux containers on top of things in the cloud. The behavior is the same. The reason to use it is similar. The capacities are similar because you can now rent anything from a sub-gigabyte machine all the way to almost a terabyte of storage, of in-memory storage on Amazon, and turn it on and off every hour. I think exactly the same is true for Hazelcast. The platform is not tied to a specific technology or prohibited from using a specific technology. As Chris said, containers and virtualizations are very good operational use choices for certain places. And when that's the right thing to use, they work with both those technologies just fine. They're not required, but they're certainly not prohibited.
Okay. Well, I know we're just about out of time, so thank you ever so much, all of our listeners and viewers, for participating in this webinar. Thank you again to Gil Teen, CTO and co-founder of Azul Systems, and also Christoph Engelbert, Manager Developer Relations at Hazelcast. Thank you from myself, Jason Stamper of 451 Research. Our email, Twitter handles, if you like, on your screens in front of you. If you'd like to continue the discussion, we'd please hope you do, and let us know what you thought and any feedback and so on. Thank you again for listening, and that's over and out from all of us, and thank you ever so much. Goodbye.
Thank you all. Bye-bye.
Thank you.